Hello everyone. So in this segment we will see the solution of the exercise that we posted in our last lecture. So in last segment we talked about function, different type of function, which is we have one-to-one function and on-to function. Okay. So let's try to find out whether this function is one-to-one or on-to. Okay. So we have here s, and the function is defined from s to z. Okay, and we have finite s value. We have 1 2 3 4. So let's find out the f of x value. Okay, so f of 1 is odd, so it will be 2 minus 1. Okay, so f of 2 is even, so it will be 2 square plus 1, so 5. So f of 3 is odd, so it will be 3 times 2, 6 minus 1, 5. Alright, and f of 4 is even, so 4 square, 16 plus 1, 16 plus 1, 17. Okay, so the function looks like okay, so that's our input and that's our output. Okay, so that's our input, that's our output. So if we put the and function, the function is going to be, the function will be actually set of ordered pairs. It will look like 1 1 1 5 3 5 and 4 17. Okay, all right. So now if we put the array, you can see that 1 to 1 I have 2 to 5 and I have 3 to 5. Okay, and 4 to 17. All right, so from that mapping we can see that actually for two input we have the same output. Okay, so f2 equals to f3, where 2 is not equals to 3. So they are different input but their output is same. Okay, so that means it's not one to one. One-to-one function means every different input will have different output. The output will be same. Okay, so if we find the output is same, that will be only possible if and only if a1 equals to a2. Other than that, okay, other than that, for every different values of input, the output is going to be different. Okay, so that is the requirement of one-to-one function. So here if we find that f2 equals to f3, all right, that means this is not a one-to-one. Now is the function is onto, this is actually, I'm not supposed to write this. Okay, so this is a set. All right, so in the set of y we have 1 5 and 17. Okay, in set we are not going to repeat the value, so the set y will look like 1 5 and 17. Okay, now the question is if the function is onto function. The function is onto function if for every value in our output has a solution from uh, from our input. Okay, so every value from our output has a solution in from our input. Okay, so here we can see that we have actually arrow from we have arrow in every value of our output. Okay, so for every value in the our output set, that has a solution in our set x. Okay, so that means that is a onto function. Every output has a solution. Okay, every means every output is possible in onto function. Every output is possible. Okay, so every output is possible because every output has an arrow from input x. Okay, So this one is a onto function. All right, so in this exercise we are seeing that we're talking about addition and multiplication of real numbers. Okay, so if we add x and y, the result will be x plus y. If we if we multiply x and y, the result will be x multiply y. Now we have to determine whether this add function or multiplication functions are one to one or onto function. Okay, so here you can see that the add and multiplication, it will generate another real number. Okay, the result will be another real number. So if we think about like as a function mapping, so our input here in this function mapping, here our input is actually any two real number. Okay, any two real number, and output will be for addition the output will be x plus y. Okay, now we can think that, let's see, if we do the function mapping, it is going to be look like, say, set of a pair of two real numbers. For example, 1 1, 1 2, 1 3, 1 4, like that. Okay, so it's an example of set of infinite set. Here actually there is a lot of possibility of ordered pairs. Okay, so the result of 1 1 for addition, add function, the result of 1 1 will be 2, the result of 1 3 will be 3. Okay, 1 2 will be 3, 1 3 will be 4, 1 4 will be 5. Okay, all right, so I'm just showing you how the function is going to look like. All right, so this is our input set, this is our output set. All right, now as we know, to let's find out for addition. As we know whether the function is one to or onto, the function is 1 to 1 if for any two for every different input the output is different. Okay, now let's find out for addition. If we find addition for 1 to 1, okay, add 1 1 equals to 2, and add 2 0 is also 2, where 1 1 is not equals to 2 0. Okay, so if we find at least one example where we can show that for different input we can find the same output, that means the function is not one to one. Okay, the function is not one to one because for two different input we are seeing that we can have the same output. Okay, all right, now is it onto? All right, now let's see, we have a in the output we are going to have a set of real numbers. Okay, in output we have set of real numbers, so the function will be onto if every output is possible. Means I can generate every output from a set of input. Okay, I mean I can generate every output from our input set. Okay, now for addition, the thing is that for every output is possible. Okay, I can generate actually every output. For example, add 1 0 will generate 1, add 2 0 will generate 2. Okay, that's how actually if I add a value with 0, okay, if I add a value with 0, then I can generate the same number. Okay, that means every output is possible by adding that number with 0. Okay, so here I will have actually at least one arrow from every output. All right, so that means this is a onto function. All right, so this is a onto function, so the addition, it's a onto function. Now let's find out multiplication. Is it 1 to 1 or is it onto? So multiplication will simply generate the multiplication. Okay, so here 1 1 will generate 1, 1 2 will generate 2, like that. Okay, so multiplication, whether this is a 1 to 1, we have to find out whether if we find any two different input that generate the same output, that means it's not one to one. Okay, so let's find out. If I can find so let's see, 1 4 equals to 4, so 2 2 equals to 4. Okay, so looks like we'll find at least one example where input is different, okay, but output is same. All right, so here 1 4 is not equals to 2 2. Okay, so it's not 1 to 1. And for multiplication, whether this is onto like addition, we will find actually the result of every output. Okay, every output is possible from the multiplication. If we add the result with 1, it will give me the value y. Okay, so that means for every value in my y set, okay, for every value for my y set, I will find a ordered pairs, okay, like that in my x. All right, for which this output is possible, means for every output is possible. Okay, so that means it's a onto function. All right, so that's the answer. Okay, so we'll talk about the rest of the topic in next segment.